Let's look at an example of how to use the definition of the derivative of a function at a point to find f prime of a for the following function. F of t equals the quantity 2t plus 1 over t minus 2. Recall that the definition for the derivative of a function at a point is here. F prime of a equals the limit as delta x approaches 0 of f of a plus delta x minus f of a over delta x. So let's go ahead and see how this works. Now, one small reminder, our definition is in terms of the variable x, but our function is in terms of the variable t. So if we're looking for f prime of a, instead of taking the limit as delta x goes to 0, we want to take the limit as delta t goes to 0 of f of a plus delta t minus f of a all over delta t. Continuing on, we have the limit as delta t approaches 0 of, now I'm replacing every instance of t in my function with a plus t. So I'm going to end up with 2 times a plus t delta t plus 1 over a plus delta t minus 2 minus then f at a, which is 2a plus 1 over a minus 2 all over delta t. Now, I need to simplify this numerator, which means that I need to get a common denominator because both parts of my numerator are rational functions. So looking at our denominators, they cannot be factored, and so our common denominator is going to be the product of our two denominators. So for my first rational function, I'm going to have, limit delta t goes to 0 of 2 times a plus delta t plus 1 over a plus delta t minus 2. And at this point, I'm just, the best I can do is multiply both numerator and denominator by the denominator of the other part of the numerator, the other rational function. So we're going to multiply by a over 2 times, a minus 2 over a minus 2. And we're going to do something similar with the second part of our numerator. We'll have 2a plus 1 over a minus 2. And since the best we can do to get a common denominator is to multiply the two denominators, we will be multiplying here by a plus delta t minus 2 over a plus delta t minus 2. Now we're going to take that whole expression over delta t. Okay, so now we have the limit as delta t approaches 0. We're going to have a common denominator across our numerator. So I'm going to designate this as my numerator, and that entire numerator will have the common denominator of a plus delta t minus 2 times a minus 2. Now, in my numerator, I'm going to have to use the distributive property to multiply things out. So I'm going to have 2 times a plus delta t times a minus 2. So that's this piece. And then plus 1 times a minus 2, continuing our distributive property. Then minus 2a plus 1 times a plus delta t minus 2. Okay, continuing onward. Oh, and forgot that whole numerator is over delta t. So as we continue with the limit as delta t approaches 0, our denominator will continue to be delta t. And we're going to use the distributive property to multiply out our numerator. So I've got a times a, and then multiplied by this coefficient of 2, so 2a squared. And then we've got a times negative 2, negative 2a. Again, this initial coefficient of 2 will make that a negative 4 minus a 4a. Continuing, we have delta t times a, so delta ta, but this initial 2 will make that 2 delta ta, and that is positive. Times a. And then we have delta t times negative 2, so negative 2 delta t, along with this initial 2 makes that a negative 4 delta t, so minus 4 delta t. Doing the same with the rest of our numerator, distributive property of we've got negative 1 times a minus 2. Well, that's still going to be just a minus 2. So we don't need to do anything there. And then distributive property and our last component, we've got 2a times a, so that's going to give us a minus 2a squared. Then we've got 2a times delta t, so that's going to give us a minus 2a delta t. And then a 2a times negative 2, so that's minus 4a. Initial minus makes that a plus 4a. And I'm running out of room here, so hold on. Okay, so I've moved this over a little bit so we can finish our distributive property, and also made space for our denominator of our numerator. So where we were was we needed to multiply now distributive property 1 times each of the components of our remaining parentheses. So, and we have a minus in front of it, so negative 1 times a is going to give us a minus a. Negative 1 times delta t is going to give us a minus delta t, and negative 1 times negative 2 is going to give us a plus 2. And our denominator for our numerator is a plus delta t minus 2. Notice that I'm dropping these parentheses around the a plus delta t. They're not necessary. and then times a minus 2. Now we're going to be searching our numerator for terms that will subtract out. So for example, I have a 2a squared and a minus 2a squared. Those will sum to 0. I've got a minus 4a and I've got a plus 4a. Those will sum to 0. I've got a plus 2 delta t a and a minus 2a delta t, and since multiplication is commutative, we can easily say that those sum to 0. We have a plus a and a minus a. Those will sum to 0. And we've got a negative 2 and a plus 2, and those will sum to 0. So while this was rather tedious and looked a little intimidating in the numerator, notice that many of the terms summed to 0. So now let's see where we're at. We have the limit as delta t goes to 0. We have negative 4 delta t and a minus delta t, so we'll say negative 5 delta t over a plus delta t minus 2 times a minus 2. Now, dividing by delta t is essentially the same as multiplying by 1 over delta t. I'm just finding it more convenient to write it that way. And now notice that we have multiplication and a common factor in the numerator and denominator of delta t. So those will divide out, leaving me with the limit as delta t approaches 0 of negative 5 over a plus delta t minus 2 times a minus 2. And now I have a form that I can consider using and asking the question, what happens to this function as delta t approaches 0? Notice that I could not ask that question in the previous step, because as delta t went to 0, that meant I had a denominator going to 0. So it was not until I was able to simplify and divide that out with the numerator that I'm actually able at this point to consider that question. So as delta t goes to 0, in my numerator, negative 5 heads to negative 5. And as delta t goes to 0, in my denominator, my first factor will head towards a plus 0 minus 2. And my second factor is not affected by that, so it will remain at a minus 2. So we end up with negative 5 over the quantity a minus 2 squared. So what we've found is that f prime of a for this function is equal to negative 5 times the over the quantity a minus 2 squared. I hope this helps.